Hey, hi there again, Scott here. Got a question from a student about epsilons and deltas. So this is we're using them to try to make rigorous our intuition in calculus. And give an example here. So we can think of epsilon as the error between f of x and a limit. So if we know the limit as x approaches a of f of x is L, we can keep f of x like within a small error from L by taking x, the distance between x and a sufficiently small. So for example, for x squared, we know that as x approaches 3, x squared approaches 9. And then we can find, so we can keep x squared within 0.1 of 9, for example, by keeping x sufficiently close to 3. So looking at this, let's see, just a rough sketch of x squared. So at x equals 3, y equals 9, and we can find we want to keep we know that as x approaches 3, y approaches 9, we want to find value or distance around 9, or around 3, so that the y value is within 0.1 of 9. So we want that distance to be, or that error to be 0.1. So we want f of x to stay within 0.1 of 9, so between 8.9 and 9.1. So we can solve for x. So let's see. So we're trying to solve for x, so that x squared is between 8.9 and 9.1. So if we get x at those 2 points, like the x value for 8.9 and for 9.1, then when we solve that, we take the square root and then 2.9832 and 3.0166. So we can mark those points. Let's see. So at x, those two values give y equals 8.9 and 9.1, and we can check the error, or how far away those points are from 3, those x values. And so the first one is 0.0168 to the left, and then 0.0166 to the right. So as long as we keep, so the maximum distance would be 0.0168. So as long as we stay within 0.0168 of 3, we know the y values will stay within 0.1 of 9. So that's so we took epsilon equals 0.1, and then we found that delta is 0.0168. So I hope that makes sense. Let me know if you have any questions. Otherwise, good day.